The next reaction we're going to look at is kind of a review that we've already covered before, so it should go a little bit quick, or at least be familiar to you, and that's the esterification reactions. When we talked about the esters back in the naming part of the unit, we talked about how they're made from a carboxylic acid and an alcohol combining, and that each of those pieces forms a specific part of the molecule. We're just going to review that now because that's the reaction, the esterification reaction that creates the esters. So let's show an example here. So let's say you start with, I'm going to use a couple different colors here. Let's say you start with ethanoic acid. So we have a molecule here, 2 carbons with a carboxylic acid group. So we'll name that ethanoic acid. And let's react that with an alcohol. Let's say, keep things simple here, let's say methanol. Alright, so there's our reaction, those two combining. Now what happens here, let's get into a little bit more detail than what we did before. What's going to happen here is, let me use a different color. This OH right here and this H right here, they go off together and they're going to recombine into the OH and the H into a water molecule. So now we have an HOH or a water. And what happens with the rest of it is that oxygen from the carboxylic acid, show this, is gone, right? It was removed, that OH left. And so the oxygen that's left from that alcohol, from the methanol, is going to kind of rotate in and plug itself in right here. And so the rest of that alcohol with the methyl part is just stuck out there. So now remember, when we name these, the parent is always where the O is pointing. So remember that the O's here are pointing that way. So the 2-carbon chain is the parent that comes from the carboxylic acid, and the other is the branch. So in this case, this would be a methyl, and then with the blue, ethanoate, like that. Okay? Okay, let me do one more example like this, and then I'll show you the reverse. What if they give you the ester? Okay, the next one looks like this. What if we had like a benzenoic acid? We have a benzene parent that has a carboxylic acid group. Benzoic acid. And let's combine that with, we'll just do a line here to make this a little faster. Propan 1-ol. Okay. Now, when we recombine these, if we remember that this complete OH is going to come off and that H is going to come off, then we know we're going to get as our first product, let's start here, that water molecule, like this. And then we're going to have our benzene out to a carbon, double bonded to an O, and then we're going to have the O from the alcohol, and then it was propanol, so then we're going to have 3 more carbons here. So might have to curve this just to fit it on the page, but kind of like that. So if you have more room, I would just straighten that out. But then in terms of the naming, this will be a propyl because of the 3-carbon branch, and then benzoate. And I think it has to do with, the reason we dropped the not benzenoate is there's some rules in there that have to do with whether you drop, kind of like we drop the E, except if there was more than one alcohol. Benzoate sounds a little better than benzenoate. I'm not going to get that picky, so don't worry about that part of the naming, like if it was a benzenoate or a benzoate. I won't get that picky on you guys. But that's kind of the idea. Okay, so hopefully that makes sense. Now let me show you one in the reverse, because sometimes they'll show you the carboxylic acid and the alcohol and you got to come up with the ester. Sometimes they're going to show you the ester and you got to work backwards. So let's say they give you this. Okay. Now remember, the O's are attached to the parent. So these three are the parent and this one is the branch. So the name of this would be methyl, and then we've got a 3 carbon, so propan O8. Okay, so that would be the name. And if the question asks you what carboxylic acid and what alcohol would be used to create this ester, remember the branch comes from the alcohol. So if a methyl branch, it would be made from methanol. Oops, I don't need methanol. And remember, if you get bigger alcohols like 3 and bigger, you'd have to say propan-1-ol or butan-1-ol or something like that, because it needs to be on the end. And then the other part is your parent. It's in this case 3 carbons, so that's a propan, and it had to have been a carboxylic acid, so it's a propanoic acid. And that's it. So for these ones, you need to make sure that you're familiar with it enough that you could go either way. You know how to turn a carboxylic acid and an alcohol into an ester, and you should be able to do, if I give you the ester, you should be able to tell me the carboxylic acid and the alcohol that you'd have to use if you wanted to make that particular ester. So if there's anything in there that you're having trouble with or doesn't make sense, let me know. Hopefully this is a bit of a review, but if there's any lingering things that are bothering you, just let me know. I'll try to fix it.